With my golf game coming to end, I thought it might be interesting to show some of the stuff I've been experimenting for my next project, which is going to be a kind of Starship Tactics battling game. I want it's going to have more UI, so I wanted an easy way to put UI together. And I thought about using SwiftUI. I used SwiftUI in the golf game, but I thought it might be interesting to look at how SwiftUI worked and kind of try and build my own similar DSL, but rather than using Mac OS controls and iOS controls rendered natively to Metal and the GPU. So I thought it was quite interesting. So what you can see on the screen at the moment is just an example view. You can see it looks somewhat SwiftUI like, and we'll get into it a little bit more in a second. I'm just going to run it first so you can see what the output of this is. It's also going to be rendering the sort of the Starship Tactics game underneath. I'm not going to go into the code of that here, but yeah, let me just run up the demo. Okay, so you can see there's a little panel appeared in the sort of game view, and it contains things that we could see in the source code. So I'll stop that demo now. Yeah, there's a few. It is very SwiftUI-like. There's a few differences. So one of the things I'm trying to do with this is it says use Metal, and I'm using instance rendering to kind of create the UI. So it's using an instance buffer. And one of the things I'm trying to do is not change the size of the instance buffer. That's a sort of reallocation. And it's not tons of data, so it's not the end of the world, but I'm trying to keep things fairly clean and just update the parts of the instance buffer that require updating. Often it's only a small part of the UI that's changing. So there's a few differences to kind of support that. One is, although you can put branching logic in here, and I'll show you some branching logic in a minute, if you do branching logic, the system's got no way of figuring out how much data, how much space to reserve the instance buffer for that part of a UI. So I've also introduced a visibility modifier that will still allow the allocations to be made, allow the instance buffer to be constructed in full, but won't show those things. You can kind of toggle them on and off, and it'll update the instance buffer to support that, sort of preventing the reallocations. But otherwise, it is very SwiftUI-like. I should say the text is a little bit different too. So the text is rendering to a composite texture. So it gathers up all the text that's to be displayed and pops it on a single texture. And then it uses offsets into that texture when it's pulling out the when it's rendering the UI to just put those little bits of texture on the screen, rather than have lots of tiny textures around. There's one large texture that's just loaded at once. That's great for static text. It's not so great for text that's changing all the time. Say, a number that represents, so the position of something that's moving, that could be changing all the time. So I will probably introduce something that better supports dynamic text. Also, that will probably just on a per frame basis, but it'll be better designed for sort of frequent update. But it might be that I end up updating the same texture. I've not got to it yet, or it might be that I create a new texture that's for dynamic stuff. Need to see. I'm feeling my way through this a little bit. I know what I kind of want at the end, but there's a lot of moving parts between tree building, rendering, tree diffing. There's quite a lot going on, so I'm definitely feeling my way through it a little bit. Game button is not actually a built-in control. Text is built in, VStack is built in, is into the MetalUI framework. Game button is a control I've written to support my game. Buttons, again, they follow the same kind of patterns. I've got hover and pressed as modifiers on the buttons, and that just allows the instance buffer data to be, kind of preserved, to be allocated rather, and made visible or not based on the state of what's going on. So it's little changes like that that making it more metal friendly, that are kind of altering how it works. But you can see it just works like a normal Swift UI type view otherwise. And it does support binding, so I go back to the code we're looking at, and hopefully this is still on my clipboard. If I take that position out and put in this position, let me just show it first. So if I run that, the panel's now kind of tracking the Starship. The panel's tracking the Starship, and if we look at the code for that, you can see that the position's been changed to use a binding on the game object, to bind to a game object, and I've introduced this concept of a translation. So we've obviously got two sets of coordinate space going on. We've got the UI coordinate space, which is 2D. I mean, technically it's 3D, but we're representing it as 2D for convenience. Then we've got the kind of the game world space, which is 3D. and using projection matrices and things like that. Translations are going on. All that kind of stuff's happening in there. So what the translation part of the position lets you do, and it's optional, is convert your coordinate space. So take the value that's in the binding and convert it into user interface space, and that's how we can kind of track a 3D object in the user interface fairly straightforwardly. Yeah, and finally, the kind of graphics and things that are in here are very basic because they're drawn by me, but they're voxel based, and I kind of drew them in the voxel editor that I have on the App Store. Small ad, I say it's an ad, totally free, so I don't make money off it, but go and download it, show me some support, yay! Yeah, so I've been using my little voxel editor to do that, and yeah, so I'm progressing through it. It's super early, so it's open source already. I'll pop the link in the comments, sorry, below the video rather, in the notes, but it's super early. It's going to change quite a bit as I feel my way through this, but yeah, thought I'd just share where I was at. It's been super fun. I've learned quite a bit about Swift and an awful lot about how SwiftUI works, and it's been really fascinating. Yeah, great.